In this lesson, you will recognize angle conditions that occur with parallel lines and prove that two lines are parallel based on given angle relationships. How do you know that the sides of a parking space are parallel? Have you ever been in a tall building and looked down at a parking lot? The parking lot is full of segments that appear to be parallel. The workers who paint these lines must be certain that they are parallel. When each stripe of a parking space intersects the center line, the angles formed are corresponding angles. If the lines are parallel, we know that corresponding angles are congruent. Conversely, if corresponding angles are congruent, then the lines must be parallel. This is postulate 3.4, so it's assumed true without proof. If two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. If given a line and a point not on a line, then there exists exactly one line through the point that is parallel to the given line. If two lines in a plane are cut by transversal so that a pair of alternate exterior angle line is congruent, then the two lines are parallel. Theorem 3.6. If two lines in a plane are cut by transversal so that a pair of consecutive interior angles is supplementary, then the lines are parallel. Theorem 3.7. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. And Theorem 3.8. In a plane, if two lines are perpendicular to the same line, then they are parallel. Determine which lines, if any, are parallel. Well, just using the linear pairs, if this angle is 77, this angle would have to be 180 minus 77 is 103. And same thing, if this angle is 100, then 180 minus 100 is 80. So 103 corresponds to the 103, so line A is parallel to line B, but for C to be parallel to A and B, instead of 80, that would need to be 77. Find X, the measure of angle ZYN, so that PQ is parallel to MN. Okay, parallel lines, they mark with the little arrows. And alternate exterior angles are congruent if lines are parallel. Solve, we want to get x on one side, so subtract 7x from both sides. Add 25 to both sides. And we have 4x equals 60. Divide by 4. And x is 15. That's our first answer. And then they said also to find the measure of angle ZYN. ZYN is 7 times x plus 35. So when we evaluate that, we get the measure of angle ZYN is 140 degrees. We're given that line L is parallel to line M, and angle 4 is congruent to angle 7. They ask us to prove that R is parallel to S. Just thinking through a plan, I can see that angle 6 is going to be supplementary to both 4 and 7, and if two angles add up to 180 with the same angle, they must be equal to each other. There's my plan. We begin by stating the given. Angle 4 and angle 6 are supplementary by the consecutive interior angle theorem. We know that supplementary angles add up to 180 degrees by the definition of supplementary angles. From step 1, we said angle 4 is congruent to angle 7. So definition of congruent angles is they have the same measure. If the measure of angle 4 is the same as angle 7, we can replace the 4 with the 7 by substitution. So that means that angle 7 and angle 6 are supplementary because that's the definition of supplementary angles. They add up to 180. So now that we have angle 7 and angle 6 supplementary, we can conclude that line R is parallel to line S because if consecutive interior angles are supplementary, then the lines are parallel. Okay, next example, we got to use some numbers to determine if lines are parallel. Determine whether line P is parallel to line Q. I'm going to do it graphically because they graphed it for me. That's nice. This line is going down 6 and over 4. The other line is going down 3 and over 2. So -6/4, if we reduce it, is the same as -3/2. So I would say, yes, the lines are parallel. We could have also done it algebraically using the slope formula. So change in y, -3 minus 3 over change in x, 0 minus -4. And I get -6/4, which reduces to -3/2. And in the other equation, the other line, change in y, 0 minus 3 over change in x, 4 minus 2. And we get the same answer algebraically as well. When lines are cut by a transversal, certain angle relationships produce parallel lines. Congruent corresponding angles, congruent alternate interior angles, congruent alternate exterior angles, or supplementary consecutive interior angles.